In today's tutorial, we're going to be learning how to grab a ledge in a platformer, often requested topic that I'm surprised I never covered. I'm assuming you have a platformer. For this tutorial, I'm going to be using my 2022 platformer as a framework, see links, etc. First of all, we'll make our lives easier if our player is working with a state machine. If you've never heard that term before, don't worry, it's not as scary as it sounds. I do have a video explaining it in detail, but all you need to know right now is that we want to separate our normal player behavior from the behavior we want to have when we're on a ledge. This will keep our logic clean, separate, and will make it easier to add other types of states and conditions without giving us a big headache. So before we get into the grab logic, let's very quickly set that up in case you don't know how. We're going to grab all of our step event logic except for our inputs up here and cut it with Control X. Then we're going to go to our create event and put it in its own function called state free. Then we're going to create a state variable, assign state free to it. Then we go back to the step event and simply write state. Run the game at this point to hopefully see everything is exactly the same as it was before. Now we have a state machine. Easy. Now we can focus on our ledge logic. All we need to work out is the exact conditions under which we grab a ledge. When you're writing a mechanic like this, it's really important to think this through carefully and consider all the consequences of your logic and any edge cases and how you want to handle them. Your own grab mechanic might work differently to mine, but I settled on the following logic. Firstly, we're touching a wall horizontally. We already checked for this, so we're off to a good start. Then, if that wall has at least one free pixel immediately above it on the side we're touching, we consider that wall to be a ledge. Finally, if the y-coordinate of our top edge passes the y-coordinate of the wall's top edge in either direction, we enter the ledge grab state. The ledge state itself will just keep us still until we press jump or something to come out of it. This is why being in a different state is helpful, because it handles stopping gravity and horizontal movement and so on for us automatically. Alright, so let's actually implement those checks. I'm going to declare a variable here before our horizontal collision check, var_@ledge equals false. Then the first thing we wanted to know is if we're touching a wall. Well, we know that here already. Technically, this also only happens when we're moving intentionally towards the wall. If you want the grab to happen just by being next to the wall, you'll need a separate check instead. But once we know this either way, we want to see if this ledge qualifies for grabbing. That is, it has space above it. So we'll say, is this a ledge? var_hoary_wall equals instance place x plus hsp y o_wall semicolon, just to get the instance ID of the specific wall we're colliding with. Then, if not position meeting hoary_wall.bbox_left hoary_wall.bbox_top -1 o_wall bracket. This checks 1 pixel above the top left corner of the wall, but what if we're coming from the right hand side? We'd want to check bbox right here instead, right? Well, rather than doing multiple ifs, we can do something slightly advanced and actually check both in one line, by first of all adding a condition to this value. Sign hsp equals 1, which will be true if hsp is positive and we're moving to the right, and then the question mark symbol. This means if this condition is true, we want this value. And if we put a colon after it and write hoary_wall.bbox_right, we'll get this value instead if the condition is false. It's a little fancy and makes the line kind of long, but I like how it saves us making another variable and another if check. So now this line asks if 1 pixel above the top corner of the wall, depending which way we're coming from, is free. If it is, @ledge becomes true. We'll use this later to confirm all of what we've checked so far is true. Then var_ledge above or below equals sign oplayer.bbox_top minus hoary_wall.bbox_top. This will give us a 1, 0, or -1, depending on if our player's top edge is above, below, or exactly level with the ledge in question. We need to know this because our final condition is to ask if we're moving past this point. So to do that, we just need to know if this value changes after we move in the y-axis. So let's come down to just past our vertical collision after committing to our y movement, and let's grab the ledge if we move past one. So if we're at the ledge using @ledge and ledge above or below is not equal to, and then copy and paste the same calculation. Then finally, it's time to grab the ledge. So let's set our y position however we want it. I'm going to use the ledge's top coordinate plus my player's y offset, which should put the top of my player flush with the top of the wall. Just put whatever sprite you're using as your collision mask into here. Then state equals state ledge. And we're good. That's the full logic of getting into the grab state. All we need to do now is actually create the ledge state. So let's pop down here and do just that. State ledge equals function, work out if we should jump, if key jump, VSB equals VSB jump, state equals state free, close brackets. This is all we need. As I said, the nice thing about this is we don't worry about gravity or our other controls or collision or anything while we're in this state. We just need to stay still and await whatever input will get us out of the state. For me, that's pressing the jump key and then getting a jump speed and then changing back to the free state. You might want some way to drop from a hang too, like pressing the down key and just falling. You'd do the exact same thing, but check a different key and don't set the jump speed. So yeah, that's absolutely everything. You can now grab ledges. Remember, first of all, we used state machines to separate the logic of the two states. Then we asked ourselves what the conditions were to get from one state to the other, checked all those conditions were true, and then changed states. That's really all there is to almost any mechanic that puts your player into new state or condition like this. So if you take that away, you'll be able to do way more than just grab ledges. For more on state machines, I really do recommend checking out my dedicated video. It's a super important concept to understand for all kinds of mechanics. If you want to have a say in what topics I cover, you can suggest them via the form linked below, but you can also vote on the final topics covered by becoming one of my Patreon supporters at $5 a month. You also help my videos exist, help me to pay my new editor to make even more videos exist, and get to download the source code. That's pretty cool too, I like to think. Thank you to all my patrons, and thank you for watching all the way to the end. Catch you all next time.